Hi, let's look at a problem which is called longest palindromic substring. So let's see what do we mean by exactly palindromic. Palindromic is it's a string which when we read from forward and backward it will be exactly same, like in this case. So here BAB, BAB, if we read from left to right it will be BAB, and if we read it from right to left it will be still BAB. So it is same from left to right and right to left, and it's called palindrome. Now let's see the question. It says given a string S, return the longest palindromic substring in S. So here if we see S equal to BAD, so if we see, like, we know each character is also a palindrome, individual characters, because when we read B from left to right it is same as right to left. But here we are asked to find the longest palindromic substring. So first we'll see how many substrings are possible here. One is B, one is BA, BAB, BABA, BA, BAD. All these are starting from the index 0, which is B. Similarly, if we see here, so here we can only find a palindrome which is BAB. And we can now see again starting from A, we have A, AB, ABA, ABAD. So here if we see, we found another palindrome which is ABA, and these all are possible substrings from index 1. Now we'll see starting from B, which will be B, BA, BAD. Here in this combination we don't find any palindromic substring other than this, so we'll ignore this. Then A and AD and D. Now if we saw our example, we found two palindromes. One is BAB, another is ABA, and it is fine to return any of this, and basically we can always find the first one, and if anything is longer than this then we can return that one. So in this case we can return BAB or ABA, that is fine. Now let's see. So this is a string of length 5. Okay, so this is for odd length, and this is another example given for even length string, so which is CBBD. And here also if we see all the substrings C, CB, CBB, CBBD, and here we don't find any palindromes other than C. Now starting with B, first B at index 1, B, BB and BBD, we see this one is a palindrome. Starting with this to second index B and BD, starting with third index which is D. So we saw there is only one longest palindrome possible, which is BB. Okay, so now as we discussed, brute force approach we can take to find all the substrings possible, and then we can see that which are the palindrome in this case. So if we see like so first we need to move from like this 0 to n in one loop, and then from I, like I will be from 0 to n, then j will from I to n, and we will check inside this if I to j is palindromic. So if we see here, time complexity is O of n cube. So now this is a brute force approach, we can try this, but this is not a very good approach, since the time complexity here is O and Q. So we can further optimize this to do it in O n of square. Let's see that. So how basically we are like figuring out if it is a palindrome or not. Let's take example of B A B. So if we see B A B, this is start and this is end. So if we compare, normally how we compare, we check if the last character is similar to the, like first character at S is similar to the last character at E. So if suppose S of S equal to S of E, then we move to inner side, like we check if the next characters are also similar. So in this case we'll be doing S plus plus and E minus minus, and we keep on checking till we reach at in a single character in case of odd, and in case of even there will be two characters, like suppose it will be B A A B. We will move from here and we'll move from here. We'll reach here, we'll compare this, and that's all in case of A1. Now to this is one approach to check palindrome. Now we can, here what we are doing, we are checking from out to in. Now we can do either a different way also, where we will move from in to out. Like if we see here, suppose B A B, this is a odd length, right? So in this case we can see this is the middle, okay? And if we check, so we know like individual character is always palindrome, so we can go this way and this way. So for example, we can define this start and end as the same index here. In case of odd length we are discussing, suppose I, then if this match, then we can go to S minus minus and E plus plus, and we can compare again as S of S equal to S of E, then it's a palindrome. We'll keep on checking till we have this S of S equal to S of E, or we reach the boundary, like S should be greater than equal to 0 and S E should be less than N, where N is length of S. Okay, so this is in case of odd length, and in case of even length, suppose similar example, so this is even length. So here what we can do is, we have two middle here, right? Or we can say the middle exists between two characters. So we can define like this as start and this as end. So suppose this is I, then it can be I plus 1. We can take either way. So we can take this as I, and this as I, and this as I minus 1. Either is fine. So now with this approach we can again check, like if S of S equal to S of E, then it's a palindrome, and we can go to this direction, right? So S will go minus minus, E will go plus plus, and this will continue again. A boundary is S should be greater than equal to 0 and E should be less than equal to N. So we can take this approach. So we will traverse the entire string here also from 0 to N, and again for each substring we'll go to left and right, so till the boundary is satisfied. So we can go up to max n length. So in this case we'll have time complexity as O(n) square, but we are not taking exactly any extra space. But when it is asked to return a substring, yes, we are creating extra space. We can say it is O of n, but since that output is expected to return a substring, so we can also say it is O of 1. Okay, so now just let us see at the pseudocode. So first step, we can do for odd, then second we can find for even. So for odd, we'll define s e as I. For even, we'll define s e as I and I plus 1. And in both cases, we will traverse from 0 to n and keep comparing s of s equal to s of e till s greater than equal to 0 and e less than n. So this s is basically our string, and this s is our start point. So don't get confused with that. Maybe I could have taken this a, but yeah, it's understood. Basically this is string, given string, and this is start point and this is end point. Okay, now see, so what we can do is, given, suppose, let's now take that, convert to s to a for better, like not to create any confusion, and see the complete code here. So we are given a string. Okay, so we can take n equal length of a, and this is the our final answer, and overall length equal to 0. Since we need to find the max length, so we are taking this overall length to find that. Now we'll loop for I in range n. Okay, now we will find for odd length. So what we will do is, we'll say s e equal to I. Now we'll compare it till while s greater than equal to 0, what we discussed, and e less than n, and a of s equal to a of e. So this we discussed. This is s greater than equal to 0, lower bound. This is upper bound, and a of s equal to a of e for palindrome. Okay, this is to check for palindrome, and if this condition satisfies, then find the length. Of substring. So here, how to find the length? If one string goes from index s to e, both included, so our length will be e minus s plus 1. So this is the length. So now our length we can find as e minus s plus 1. Now compare, if length is greater than OA length, then overall length will be length, and update the outer string, our answer result also. So it will be starting from s ending at e. So to e plus 1 as the upper bound. Now this is for odd length. Now for even length, we can say s e, and we discussed it, s will be I means e is I plus 1, and we'll have the same logic here as well. S greater than equal to 0 and e less than n, and a of s equal to a of e. Then find the length. So length will be e minus s plus 1. If length greater than o length, then equal to length, and res equal to a of s is to e plus 1. Okay, I missed one part since it's a while loop. Okay, while loop we have to put the breaking condition as well. So here s should go with minus minus, since we are going outward from middle. So s will go minus 1, e will become plus 1. Same here, s minus 1 and e plus 1. And finally at the end we will return the result. So this result will have the final substring, which is of the maximum longest palindromic substring. So maximum length, which is the palindrome. So if we see this, now this is going 0 to n. This is also we are checking 0 to n. So our overall time complexity is O(n) square. And space, we are not taking extra space other than this result variable, which is we are creating the substring. So either we can say it's O of n or O of 1, since result is asked to us. If it would not have asked and it would have just asked to return the length, it would have O of 1. But since it is asked in the question, so we can say it is either O of 1 or O of n. So I hope that clarifies this question, longest palindromic substring.
Now let's run it in Python and see the result by ourselves. Okay, so here S is a given string. So we will get the length of the string, we'll get the result string, and we will get the overall length. So here n is length of S, result is string, empty string for now, and overall length is 0. We will calculate it. Now we'll loop over the entire string. We'll check for odd length palindrome, and for even length palindrome. Okay, so for odd length we will be checking the start and end index. So let's say start end equal to I, and for even length it will be start end equal to I plus 1, what we discussed in pseudocode. Okay, so now we will see the boundary conditions. While start greater than equal to 0 and end less than n, and we'll be checking the character at start equal to character at end. If it is same, then we will do start minus minus and end plus plus till we reach the boundary. So s at start equal to s at end. If this condition is satisfying, then we'll check the length. So how we'll calculate length? Length equal to end minus start plus 1. Now, if the length is greater, so if this length is greater than overall length, means whatever the length we have found so far, then it is the palindrome with the greater length. So we'll replace it. So overall length will be length, and the result will be s of start to end plus 1. Okay, and now we will be doing start minus 1 and end plus 1, the breaking condition. Now for even also it will be exactly same. So whatever we have written here, it will be same here. So here only thing is end index, we are taking the next index. So here start greater than 0, greater than end less than n, and this condition we are checking. If that is so, length we are calculating, then we are comparing with overall length, and then we are getting the result. And start -1, end +1. So this is the for odd length palindrome, this is for even length palindrome check. Now whatever we have got, that will be our result at the end of the loop. So return result. Okay, now let's run this. Okay, here it is accepted. Now submit. So here we can see it is accepted. Okay, bit 60%. So now this is the complete code of it. Okay, this is the complete code of it. So here we can see we are going we are going from 0 to n once. So and again looping through the entire string once. So the time complexity is n square. And as discussed, space complexity will be either O of n or O of 1. Okay, that's all. Thank you so much.